Up to previous lecture, we discuss all the cases, but there is some confusion. So I'm trying to you that provide the all cases one by one, as we know that earlier inversion means when we fixing the different links one by one, then it's known as the inversion. Now we start to fixing one by one link, and then I just show you that how fixing link can generate the mechanism. As we know very well, for input link we have to find the crank or lever, and same way for output link we have to find the crank or lever. In both time there are some condition as per the Grashopp's law that we know very well, so we are applying that uh, conditions one by one. We know the for today's example we have O2B is 180 mm, BC is equal to 120 mm, CO4 is 90 mm, while O2O4 180 mm, which is given to us. Okay, every time our input angle is 45 degree, we have to take. Now we are fixing one by one link, so we ensure that okay, how the figure may be generated. Initially, we fixing the O2O4 link. Initially, we fixing the O2O4 link. Please refer this case 1 where O2O4 is fixed. In O2O4 fix, we know that how we have to draw the diagram. This is my O2O4, O2O4, where O2O4 we know very well it may be 180 mm. Now this is fixed on left side. It may be considered as a input, and every time it may be 45 degree. Okay, so at 45 degree we are getting point B. We know that BO2 is 180 mm, so it may be 180 mm. We are just take the O2 as a center 45 degree. After that we are getting the B. Now we require point C. Definitely we know that the BC is equal to 120 mm. So from this point we have to arc here, and then from point O4 O4C, or we can say that CO4, which is given to us, and that is equal to 90 mm. CO4 is 90 mm. So we are generate the first closed link for case 1. Now we have to find the input and output. Already we defined initially that O2 plus O2B plus BC is equal to 180 plus 120, means 300 mm, right now. I repeat, this is considered as A, B, C. Now we have to, and as we know that it may be a lever crank mechanism. Please follow the conditions. So it may be lever crank mechanism. Now we have to find the expansion of this input link A and output link C. Now for that, take O2 as a center, take O2 as a center, and O2, O4 is a O4 is a radius, and arc from B, and arc from no need to start from here. O2B is the radius. It is because we know that O4, O2, O4 and O2B are the equal length. So O2B is the radius and arc here. Now another arc which is required for expansion of O2B link, that is O4C plus BC. O4C plus BC. O4C is 90 mm and BC is 120 mm. Say, so that line from point O4. Okay, so O4 is a center and this is 90, this is 120, so 210. So I'm getting point B dash. Now join B dash with O2 and B dash with O4 dash. I am not taking any dimensions, so please try to draw with the proper dimension, and it may be as per the shape, it may be differ, but the instruction you have to follow strictly. While O2, O4 is fixed on that time, we are getting point B dash in this way. Now talking about B double dash and C dash and C double dash. Okay. Now before that, we know here that BC, if we talk about the angle BC, sorry, length BC, which is equal to 120 mm. While CU4, it is equal to 90 mm. Means we can say BC is greater than C. So 120, this BC is 120. BC is 120 and CO4 is 90. So we have to take the arc of 30 mm, right? BC is greater than CO4. So we get BC minus CO4 is equal to 30 mm. So that 30 mm, actually we are generate one arc here from O4 to B on that arc. On that O4 as a center and O4B double dash. O4B double dash as a radius. Means it may be O4B double dash, it may be 30 mm, right? So O4B double dash we are getting that is equal to 30 mm. If you take the scale, it is right now I can explain with 1 jam 1 scale. If you require to take 1 jam 2, then it may be 15 mm. Right now the center is O4 and B. Now join O2 bit. Now talk about the we are just complete the expansion of O2B line, which may be O2B dash and O2B double dash. Now talk about output link, that is O4C. For O4C, take O4 as a center and O4C as a radius and draw the circle. I repeat, O4 as a center and O4C is a radius and draw the circle. Now, as we know that the O4 and B, which are connected with straight line, that line should be extended. up to end of the curvature. So that is our C double dash. That is our C double dash. And the dotted line which pass from O4 and connected with B dash. I repeat, the dotted line which start from O4 and connected with B dash, which may intersect on circle at somewhere. And that is C dash. Okay? That is our C dash. Join both the point, either it may be C dash or C double dash with O4 and O4 dash. With O4 and O4 dash. Okay, so O4 C dash and O4 C double dash. This is our output link, and O2 B dash and O2 B double dash. It is our input link. Okay, this is the case one. Now I am talking about case two. Okay, now talk about case two, where we are fixing the link BO2. We are fixing the link BO2. We know very well that all the dimensions, so I am not repeat the dimension. I am fixing the BO2 line. This is B, this is O2, which is 180 mm, right? Now at 45 degree, I'm getting point C, O2, O4, and yes, it look like this. Okay, and this is called as a O4. So this is your figure of for chain mechanism where BO2 is fixed, and this is input, this is output, and this is the fixed link. So ABCD in this way. So if you follow the instruction of Grashopp's law, then you are generate the lever mechanism. Now, as we are following first case, same way we have to follow in the second case. Here, we have to provide the expansion of BC and O4, O2, O4. Means we are required to find the point C dash, C double dash, and O4 dash, O4 double dash. How? That we discuss one by one. Here we start with the finding point C dash. C dash we are getting outside of the four-bar mechanism, where C dash equal to O2O4 plus CO4. Okay, O2O4 plus CO4. It means O2 is the center, and O2O4 and CO4 is the radius. O2O4 we know 180 and CO4 is equal to 90. So 180 plus 90, 270. So from O2 as a center and 270 is the radius and R outside of the C. Okay, I repeat, O2O4 is a O2O4 is sorry, O2 is a center, and O2O4 plus CO4 means 180 plus 90, 270. Okay, so R from O2 as a center, and you can draw the arc outside of the C. Now B as a center, I want C dash. So B as a center and BC is the radius, which both are intersect at one point. It is called as a C dash. Okay. So join C dash with B, and same way join C dash with O2. So it is the discussion of first input link BC, where we get the outside one point. Now talk about the input link 1 point. Now talk about the output link O4, O2, O4 dash, O2, O4. Same thing we have to follow at here. How that to find O4 double dash, to find O4 double dash, which we meet at near to this. How we have to get that BC plus CO4. Okay, where the center is B and the radius is BC 120, CO4 90, it may be 210. So B as a center and BC plus CO4 is a radius, and it may be arc at here. And what we are performing in the previous case, same way we have to do it here. O2 is a center and O2 O4 is a radius, and arc you are at here. So it may be intersect at some point. It is called as a O4 double dash. Right. Now join with the dotted line with the fixed point, that is B and O2. Now you can see that the C dash point, which we get from BC as a center, which may intersect on dotted line of O2 C dash at somewhere. O2 C dash at somewhere. And same way, O4 line, which may intersect on dotted line at somewhere. So this is my O4 dash, and this is, sorry, yes, this is my O4 dash. This is O4 dash, and this is talk about the BC line. So it is called as a C double dash. Understood? This is BC line, so it may be known as a C double dash point and C dash point. I repeat once again, so it may be clear in your mind that I am getting O4 dash. How we are getting O4 dash? It is a summation of these two, right? And the radius is this. I am getting the arc. Now another point we are getting with the O2 as a center, and O2 O4 is radius, which may intersect at O4. Now join B with O4 double dash and O2 with O4 double dash. So we are generate the point O4 double dash. Now that arc should be intersect on this dotted line. It is called as a O4 dash, because this is the radius of O4, and same way this is the radius of BC. So we are getting the point which intersect on B O4 double dash at somewhere. It is called as a C dash dash. Okay, so in this way we are get the C dash, C double dash, O4 double dash, and O4 dash. Okay. Every time we find the input angle, means that angle between the C dash and C double dash. In the previous, if we talk, that it may be the angle between B dash and B double dash with respect to fixed point first, and same way. In the current case, O4 double dash and O4 dash. So find every time the input angle theta and output angle phi. Okay, so this is the case number 2. Now talk about the case number 3. sorry. Now talking about case 3, where BC is fixed. Where BC is fixed. Now you can just draw the figure first. We know that the dimensions BC is equal to 120 mm, CO4 90 mm, O2 180, and O2O4 is 180 mm. Okay. In first case, O2O4 fixed. In first case, O2O4 is fixed. In second case, BO2 is fixed. Now in third case, I am fixing BC, where BC is 120 mm. So we know that O4C. So this is O4, where O4C 90 mm and it may be 45 degree. Now we are generate the point O2, and we have to join this. Means O2 first O2 as a center and arc here O2 O4, which is equal to 180 mm, and BO2 is equal to also 180 mm. So both are intersected at one point. It is called as a O2 point. Now this is the fixed length. Okay. So same thing we have to apply, which we are done in the case 1. We know very well what we have to find now. We have to find the expansion of O4 and expansion of O2. Now start by expansion of O4. First of all, C as a center and O4 as a radius. Before that, the initial condition, that is ABCD, as per the uh, as per the input and output link, we know very well that if the input A plus D is less than B plus C, then A is considered as a crank, and if A plus D is greater than, then A is considered as a lever. So same thing we are follow at here, and same way for the output. C plus D is greater than A plus B, and C plus D is less than A plus B. Then it may be considered as a lever and crank respectively. So from the ABCD, we are find that it may be known as a crank lever mechanism. It may be known as a crank lever mechanism. Okay, please ensure with crank lever mechanism. Now we have to start to do the expansion of C as a center, CO4 is a radius, and draw the circle. I repeat, C as a center and CO4 is a radius, and draw the circle. Now, already we drawn the circle, means at any point we are get the O4 dash and O4 double dash, but definitely it may be on this circle because it may be considered as a crank. So where O4 O4 double dash and O4, for that B as a center, B as a center, and BO2 as a radius, and that you should continue, which may intersect on circle below point C. It is your O4 double dash. It is your O4 double dash. Right? It means we are directly generate O4 double dash. Now you can see here, you pass O4 double dash point with C point that may intersect on that O2 arc at somewhere. It is called as a O2 double dash. I repeat, because this is the line of O2. B as a center, I repeat, B as a center, and BO2 is the radius, and draw the arc which may pass below the C at point, which may intersect below the C at point O4 double dash. Now join O4 double dash with C and extend that line up to O2 double dash. Okay. Now yet we require O4 dash and O2 dash. Okay, so for that, to generate the point O2 dash, O2 dash, we require the summation of O2O4 plus O4C, right? Means 90 plus 180. Total equal to 270 and the center is C. So from point C, draw the arc of 270. It means it is these plus these and draw the arc. That is 90 plus 180, so 270. Now B as a center and BO2 is a radius. Both are intersect at one point. It is our O2 dash. It is our O2 dash. Now join O2 dash with C and with B with dotted line only. Okay, and that dotted line are intersect on the crank circle at some point, which is our O4 dash, which is our O4 dash. Means we are generate the point O4 dash and O4 double dash, which I circle, join or find the angle between O4 dash, C, O4 double dash, and O4 C, O4 dash, C, and O4 double dash, and find the angle between O2 dash, O2 double dash, B, and O2 dash also. Okay, this is called our theta or input angle, and that is called as a phi or output angle. It is called as our third case, case 3, where BC is fixed. Now, case number 4, which is very easy. This is 45 degree. O4C is fixed, where O4C, the dimension are given to us. So as per the dimension, O4C is 90 mm, which is the smallest line. You remember that, which is the smallest line of our uh, case. Data, uh, O4 O2, it is 180 mm. This is PD, and with the crank mechanism. And you remember one thing, that whenever crank mechanism is there, it means that it may revolve in its own axis with infinity. Means O4 is the center and O4 O2 is the radius, and draw the arc. We have generate one circle. It means that O4 on fixing the O4 center, and O2 may revolve in its own axis. Same way, C is the center and CB is the radius, and draw the arc, draw the circle, which may also rotate infinitively, where C is, I repeat, C is the center and CB is the radius. Okay, so there is no any constraint regarding crank mechanism for input and output, it may rotate in infinity. So on that time, you only circle. Okay, so in this way, we are complete the all three cases as per your requirement. If yet you have any query, then you may raise the query, or you may just ask me whenever you find any query. Okay. Thank you.